Okay, writing equations. So writing equations for both sine and cosine can be a little bit tricky. Usually there's a path of least resistance, and I always do the easy one first. So as we're looking at this first graph, I like to mark some things. I need to mark the period of the function and whether I think it's better as sine and cosine. So first, looks like that I go through 0, 0, so that's a good starting point. One period of the function starting at 0, 0 is out here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 pi is what's marked. That means this is scaled in pi. So 1, 2, 3. So this is 3 pi. 4, 5, 6. There's 6 pi. So the period of this function is 6 pi. And this function, since it starts at 0, 0, the easier equation is going to be sine. So I'm going to go ahead and start my sine equation. The equation that I can do without a phase shift is sine. My midline is on the x-axis, so I don't have a vertical shift. I'm going to go ahead and make that a +0 if I can. My wave goes down and then up for sine, so I have a reflection over the x-axis. And it's marked there that this goes from -5 to 5, so the amplitude of my function, the distance, the height of my curve, or my wave from the midline is 5. Now the only thing we have to deal with is that number in front of x. So since the normal period of a function is 2 pi, the period of this guy is 6 pi. So the way we do that math, 2 pi divided by some number, that's our b, is 6 pi. So I can kind of multiply my b over, if you want to do every little step here. 2 pi equals 6 pi b. Divide by 6 pi. I'm sure some of you just saw this in your head already, but that's fine. The pi's cancel. 2 over 6 is 1/3. So our b is 1/3. Again, the math with this is really simple. It's what's knowing what to do with. Okay, so the nice thing about writing equations for both sine and cosine here is that I can take the amplitude is going to be the same for my cosine graph. The number in front of x is going to be the same. And the vertical shift is going to be the same. The only thing that changes is whether I want that reflection or not, and my phase shift. Okay, so I'm going to go ahead and start this on this maximum. So that here, again, it's going to be right in between 0 and -3 pi. So what's right in between, or what's half of 3 pi? Well, 3 pi over 2. So the phase shift that I need for cosine, again, I'm starting at a maximum, so I don't need a negative out front. The phase shift that I need for cosine is 3 pi over 2 to the left. So left is going to be plus. And if you want, you can put an extra set of parentheses in here and put that 3 pi over 2 in, and that's perfect. Absolutely perfect. You have to remember that extra set of parentheses. If you think you're in danger of not remembering that extra set of parentheses, then you need to do the math that we've been kind of doing backwards there, where we do C over B is our phase shift. So C over B is our phase shift. Our phase shift is 3 pi over 2. But we know B. B is 1/3. So C over 1/3 equals 3 pi over 2. And the way we undo division there to get C all by itself is to multiply. So I'm going to multiply both sides by 1/3. And there my 3's cancel. So I end up with pi over 2. So if you don't have any parentheses there, that has to be a pi over 2. If you have parentheses, it can be a 3 pi over 2. Remember, there are an infinite number of ways that you can write these equations since the functions just repeat. So if you have a different equation than I do, it could be right. And what I would suggest that you do while you're prepping for the test is just pull up Desmos on your phone and graph them in Desmos. Desmos is really easy to use. It's actually easier to use than a graphing calculator for this.